Hello, my name is Brian Mock from ECS, and thank you for taking the time to watch today's Chalk Talk, where we discuss about reverse future-proofing your machine vision system. I know that sounds kind of crazy, so I'm going to let these pictures in the background do most of the talking for this section. You'll see a series of two pictures of the same position. One's going to be the legacy Gigabit Ethernet technology most of the industry has been using since about 2005, and the second picture for each position is going to show you the Baumer smart camera technology. This Chalk Talk is going to walk us through how we upgrade from the older technology to the new technology. Number one, we're going to give you what we call a new soul. We're going to remove all these individual capture units and give you a single Dell virtualized server running the ECS SmartFlex software. That allows you to run both the legacy Gigabit cameras as well as the smart cameras at the same time. This allows you, once you get the virtualized server, to go in and upgrade the most critical positions first and then upgrade the later positions through time. This gives you several distinct advantages. Number one, you get to preserve the greatest investment you've probably made in your machine vision, and that is the infrastructure, the Ethernet, the electrical, the air that you've already done. Number two, this takes essentially zero downtime. We're just going to replace the computers because the software can run the existing cameras as they are. Number three, you get the advantages of running smart camera technology. So you give your operators the highest resolution, the highest frame rate possible. And then number four, you get to do it now. You do not have to rip out everything and start over from scratch. And then the last thing is it's a virtualized system, which means this should be the last camera system you should have to purchase for your paper mill. Our next step is to walk you through the upgrade process with this example behind me to the SmartFlex platform. This is a 20 camera system with standard Gigabit Ethernet legacy technology at the front end, connected to junction boxes, and then the junction box convert to fiber or copper back to a host of 7 different capture computers in this particular technology. I want to start with the end in mind, and really the end in mind is this right here. This is the ECS SmartFlex software designed to work in a virtualized platform. All other aspects of the solution you can actually purchase yourself. We are proud partners with Baumer smart cameras, smart vision LEDs, as well as we currently use the Dell PowerEdge 760 series, though you can use your own computer, be it HP or Lenovo or any other compliant virtualized server. So once you have that there, the type of cameras, I have examples here that we're going to support, are the analog cameras that go back 25 years or more ago. This may be familiar to you, BNC connectors. This is another version of that same analog camera right here. We can also support, this is an old DALSA Carico camera, which is the first of some of the Gigabit Ethernet right here you can see on the back. We've got a bunch of Allied Vision cameras that we work with. This happens to be a GC 1280, 1290, the Mako, the Manta, all of those cameras that we work with. We also can integrate within the same system platform what we call Internet Protocol cameras. This is a Axis camera. It's a low-cost smart camera that's very effective where you might have positions that you still need the modern higher resolution cameras but without the cost. Very effective, for example, in converting applications. All of that can be combined into and with a Baumer smart camera at any one of those positions. So at the end of the day, starting with the end in mind, is the ECS SmartFlex software. So now I'm going to walk you through the differences in resolution and frame rate between the legacy Gigabit Ethernet technology, which has been around since 2005 or so, and what the smart camera technology can provide. Both of these are going to use the same backbone that you already have on your paper machine, which is either fiber or Ethernet on these cameras. So when it comes to resolution, we'll talk about that first. Way back in, say, 1995, we had analog cameras. Those cameras had a maximum resolution of VGA, which is 640 by 480, and that is 300 and so thousand pixels per image. So let's put VGA right here at 300,000 pixels per image. With the Gigabit Ethernet, again the legacy Gigabit Ethernet, that caps out at about 1.7 million pixels per image at 60 frames per second. We'll talk about frame rate in a second. It can do no more than that at 60 frames per second. Smart camera technology, though, opens up this huge window up here up to maybe 12 million pixels per image, and I'm going to call that 6x HD, and the HD window is about 2 million pixels per image, which is about right here. So this is HD. So the partner to resolution is frame rate. It's like a seesaw. You get high of one, you have to get a little bit lower on the other, and then it seesaws the other way. When you're dealing with this type of technology, which again is the old legacy Gigabit Ethernet, you have a pretty significant ceiling that you can go no further. Why is that? That is, the pipe under which you must send that data from the camera to the computer is a standard set pipe. It's 1 gigabit per second. That's your Ethernet or your fiber line. It can send no more data than what it can shove in that pipe. You have two options if you want to send more data. You can rip out your whole backbone and install a 10 gigabit per camera backbone, which can be costly and expensive and complicated to run that much data down the highway, or you can compress the image and do the image processing at the camera. That's what the smart camera does. So let's draw out the frame rate curves down here. Traditionally, in paper, when you're dealing with both VGA or analog video, and then with Gigabit, you're living in at about a 60 images per second world, maybe 100 at times, and maybe up to 200 before the resolution drops significantly, that it doesn't become, the video has no value. With smart cameras, it opens up a whole world of video down here in terms of the frame rate, up to 1,000 plus frames per second at significant resolutions. So when you're dealing with the passive raw video technology that you have here on legacy Gigabit Ethernet, your world is way down here. There is no way to get to higher frame rate and higher resolutions because the pipe won't support it. The data won't fit. So with a smart camera, we can live way up here, whereas with the traditional Gigabit Ethernet, you have a huge gap that you cannot cover when you have the technology of legacy Gigabit Ethernet. And analog, of course, is way back down here. So why is frame rate important? And we talk about resolution. I use the rule of 3,600. 3,600 is this, at 3,600 feet per minute. And we know paper machines can run from a couple hundred up to 1,000, 6,000, 7,000 feet per minute, but this is kind of the rule of thumb I use here. At 60 frames per second, 60 frames per second, you're going to move 12 inches from frame 0 to frame 1, and then another 12 inches over to frame 2 right there. If you're running faster than 3,600 feet per minute, you're actually going to miss data. It's called data loss, if your field of view is less than 12 inches. It becomes really problematic, though, at the higher machine speeds when you're still running at 60 frames per second, even with larger fields of view. 7,200 feet per minute, you're going to have 24 inches. There's a lot of areas that are critical on your paper machine that you cannot get 24 inches of pure sheet coverage. When you get less than that, you're actually losing edge crack clarity. You're losing the data you need to also have understanding of paper breaks, and you're losing the data to put that into advanced processing. That's the sheet behavior and web inspection. So with smart cameras, we're able to get the higher data rate and the higher resolution. And how is it doing that? Again, we talk about the work that the passive technology has to do. You've got your camera that's out in the field. It's sending all the raw video across that backbone to a bank of computers, several computers it has to do. And inside that computer, you've got compression, you've got processing, or image processing, and you've got storage. So what could you do if you could move 2 out of those 3 into this camera? So now the camera is doing the heavy lifting, so all it's sending is compressed images across that existing backbone to essentially what becomes a virtualized storage device. The other problem you run into with these traditional technologies is that sometimes you'll run multiple cameras into a single junction box, and then that junction box has a 1 gigabit pipe back to the capture computers that are what I call outside the mill IT boundary. So when you want to then upgrade this to higher resolution, there's a problem because you've already reduced the resolution of that camera because you've got 1, 2, 3, 4 cameras, and keep in mind, any one camera can completely fill up that 1 gigabit per second pipe, even one camera. So when you have 4 or more or 2 or more cameras running through that 1 gigabit pipe, you have to reduce both the frame rate and the resolution to shove all that raw data back to the computer. So with ECS SmartFlex, we're able to keep all of this infrastructure because we can compress the data at the camera, still use the same highway, and get you the much higher frame rate and resolution. What does that do for you? It allows more information to the operators. It's a pair technology. It's reactive in that you want to see the greatest and highest amount of quality pixels for the understanding of paper breaks. But if the pixels are good enough and of quality, then you can run advanced algorithms. That would be web inspection, sheet behavior analysis, to predict before or alarm you of conditions that shouldn't occur before the sheet break happens. But in order to do that, you've got to have the quality of the pixels and you've got to have the quantity of pixels. And pretty much the best way and only way to get there is with a smart camera technology. And with ECS SmartFlex, we can get you this technology with the existing infrastructure that you already have. So now that we've talked about the differences between legacy Gigabit Ethernet technology and smart camera technology, let's see how this plays out and draw out the upgrade of an existing 20 camera system where we're going to replace the soul, that is those 6 capture computers, with a virtualized server, and then point out and pick certain very critical positions, upgrade those to smart cameras while maintaining the rest of the system, including the infrastructure. So this is the outline of the paper machine. This also had an off-machine winder at the end of the process as well. They installed approximately 8 cameras on each side of the paper machine. And they've got 4 cameras or so on the off-machine winder. In addition to that, they have a backbone where they've combined anywhere from 1 to 4 cameras per junction box here. Sometimes it's 1 camera, and then sometimes it's more than that. They've done that on both the front side and the back side. Then from this junction box, they'll run a piece of fiber to a dedicated interface cabinet. Inside that dedicated interface cabinet is switch hardware, more media converters to turn the fiber back into copper, and then those are connected into 6 different capture computers. Then there is also the playback and the mill network, which we're going to be reusing that part of it as well. There are a couple problems with this off the bat. Number one, for this infrastructure that they have here, they've combined multiple Gigabit Ethernet, which again is a passive raw camera, into 1 gigabit per second stream. They've already had to reduce the resolution of those cameras in order to send more than 1 camera down that pipe. If you're sending up to 4 cameras, then you've had to reduce the resolution even more. What does that mean on this paper machine that's running over 3,000 feet per minute? There are several cameras in the wait-in that had data loss. They had lower data rate than what they needed to see every piece of paper going in front of that camera. The other challenge to this system is that you've got all of this camera information being sent to computers, capture computers, that are running Windows NT or Windows XP. So if one of those capture computers fails, it's a very challenging time in order to get that new capture computer to run with legacy unsupported software. So in a smart camera SmartFlex upgrade, what we're going to do is we're going to rip out all of these computers here and we're going to replace it with 1 virtualized Dell server. If you were to do a 180 in that NCC room, you would see right behind them the computers that run the QCS and the DCS. That's also a Dell PowerEdge computer. Spare commonality and spare parts. Spare commonality and spare parts, so that if a new hard drive is needed, they don't necessarily have to go to us to get that hard drive. It's the same spare part they already use in other parts of the mill. We're going to reuse, though, the switch hardware right here. We're going to reuse every aspect of the backbone. We're going to reuse every aspect of this junction box that has the media converter in it. We're going to reuse the air, reuse the power, and reuse the Ethernet and the other signals that go right up to the camera and to the light. Essentially, we're going to remove the camera and the light, use the hardware, and then in 4 positions in the wait-in, replace it with an LED technology. We'll talk about that in another Chalk Talk, and the smart camera technology. So at the end of the day, they have a virtualized soul of the system. That essentially is the last camera system that they're going to have to maintain because it is operating system agnostic with the virtualization. Second of all, they're still going to have their playbacks that are connected through their existing network that's there, and they also have connection to their mill-wide network so they can review the software and control it from any computer connected to the mill-wide network. At the end of the day, they get the complete advantages of smart camera technology while still maintaining their existing legacy Gigabit Ethernet cameras until they want to change those out at a future time. so they get the best of both worlds without having to rip everything out and start over again. Thank you for your time today and allowing me to walk you through how you reverse future-proof your existing camera system by taking smart cameras, connecting those to virtualized servers, and nesting that within your existing infrastructure. This picture behind me is John Larkin, the other owner of ECS. John and I and our team have been crawling around paper machines since the mid-90s, almost 30 years. We love what we do, and we love bringing new technologies to the papermaker. Please stay tuned for additional Chalk Talks this year as we discuss the challenges and solutions for the paper industry for quality control and how machine vision is solving those problems. Until then, thank you.